Not a dramatic Hollywood wasteland, just flat, cracked earth baking under a relentless New Mexico sun, where the annual rainfall barely hits 12 inches. Now, picture a garden thriving in the middle of it. Corn standing tall, squash spreading wide, beans climbing everything they can reach. No irrigation pipes, no water pump, no well visible anywhere near the plot. And the people tending this garden, they've been growing food this way, in this exact location, using this exact design, for roughly 800 years without stopping. That image is not a myth. It is not a thought experiment. It is documented. It is real. And by the end of this video, you will know exactly how to replicate it in your own yard. Whether you live in Arizona, southern Spain, central Australia, or anywhere else where water costs money and summer shows no mercy. But here is what I need you to understand first. This system, this beautifully elegant, centuries-old answer to desert growing, is quietly illegal in dozens of American cities today. Not because it harms anyone, not because it wastes resources. In fact, quite the opposite. It is technically non-compliant with zoning codes in cities like Orlando, Miami Shores, and Tulsa, where local ordinances restrict what can grow in your front yard and how soil can be shaped on your property. The rules were written for lawns, for grass, for the kind of tidy, decorative, water-guzzling monoculture that a landscape company can maintain, for a fee. Think about that for a moment. An 800-year-old water-saving garden technique developed by people who turned raw desert into a food system that sustained entire communities. And, in 2026, you might need to file a variance application to use it. I want you to hold that thought. We will come back to it. Here is the situation that makes this knowledge urgent, not just interesting. Modern agriculture consumes approximately 70% of the world's freshwater supply. 70%. And a significant chunk of that water is simply lost, evaporated before it ever reaches a root, sprayed across the surface where wind carries it away, or funneled through leaky infrastructure that dates back to the 1950s. Meanwhile, the global home gardener is being told to water deeply, water frequently, and buy the right irrigation product to keep that schedule from killing their plants. The drip system industry is worth billions. The sprinkler industry is worth billions more. Municipal water bills for households with gardens have risen consistently across the American Southwest over the past 2 decades. And none of this is necessary if you understand what the Zuni people understood 8 centuries ago: that the real problem was never finding more water. The real problem was learning to keep the water you already had. The Ashiwi, the people most of us know as the Zuni, have been farming the high desert of present-day New Mexico for roughly 4,000 years. 4 millennia of observation, failure, adjustment, and refinement. Somewhere around the 12th century, they developed a specific technique they called latekwi, a Zuni word for a sunken garden system that, when viewed from above, looks exactly like the surface of a waffle. Grid after grid of small recessed squares, each bordered by low earthen walls, tessellating across a garden bed that is already set below the level of the surrounding ground. And before you picture raised beds, stop. This is the opposite. This is anti-raised bed gardening, where a raised bed lifts soil up into the air, making it dry out faster, making it more vulnerable to wind, making it an object of zoning scrutiny. The waffle garden drops soil down. It works with gravity instead of fighting it. And that single difference in geometry changes almost everything about how a garden responds to water, heat, and drought. I want to tell you about a woman named Reina Bantea. She is a Zuni farmer from the Crow clan, founder of a small, sustainable farm in Albuquerque called Tsuya Farm. Tsuya, meaning hummingbird in Zuni. In 2018, she began reviving traditional waffle garden practices in urban New Mexico, working with Zuni youth and native seed varieties that had been adapted over centuries to the specific pressures of a semi-arid landscape. When she plants, she is not experimenting. She is inheriting. There is a direct line from the women who carried earthen jars of water from the Zuni River to their sunken garden squares, all the way to what Bantea is doing today in Albuquerque's South Valley. The knowledge nearly died. Around World War II, the widespread adoption of modern irrigation infrastructure and government agricultural programs began replacing traditional Pueblo farming methods with standardized approaches. Fertilizer schedules, water schedules, crop varieties designed for yield and transport, not for dryness or taste. Within a generation, many families had stopped practicing waffle gardening entirely. Not because it stopped working, because the machine offered an easier path. And, like most easier paths, it came with a bill that kept arriving, every single month, until the water company raised the rate. Stay with me, because the science behind why this works is genuinely one of the more elegant things I have ever researched. I will break it down fully in a few minutes, but I want to tease one part right now. There is a specific phenomenon that happens inside a waffle garden grid that you would not expect from something so simple. It involves thermodynamics, capillary action, and the surprisingly sophisticated behavior of desert soil. I will get to it after I explain the full history, because once you understand where this came from, the science lands completely differently. Here is the first mechanism. Think of your soil like a bathtub. A raised bed is a bathtub with a hole drilled in the bottom. Water runs in, water runs out, and what stays is mostly luck and the speed of your roots. A waffle garden is a bathtub with sealed corners, slightly recessed below ground level, and surrounded by low walls that prevent water from escaping sideways. When rain hits, or when you water by hand, it collects in that square. Every drop that falls inside those earthen borders has nowhere to go but down. The Zuni positioned these squares to be roughly the size of a single planting cluster, typically 12 to 18 inches per side, though some records show them as large as 36 inches for crops like squash. The depth of the recess was usually 2 to 4 inches below the surrounding soil grade. The borders, the waffle walls, were compacted earth, often 4 to 6 inches tall above the bed floor and 4 inches wide at the base, making them remarkably stable even after heavy rainfall. Now here is where it gets interesting. Those earthen borders do something that nobody talks about. They cast shade. The sun in New Mexico hits at a steep angle for much of the year, and those small walls throw a narrow band of shadow across part of each planting square for several hours each day. That shadow reduces direct evaporation from the soil surface. It lowers the microclimate temperature inside the square by as much as 5 to 8 degrees Fahrenheit compared to open, flat ground beside it. In a desert, where evaporation rates can exceed precipitation rates by a factor of 10, a 5-degree reduction is not a small thing. It is the difference between a moist root zone and a dry one. That is the thermodynamic piece. The biology is even better. Because the waffle design keeps moisture concentrated in a specific defined space, roots do not spread randomly searching for water. They go deep. In arid soils, most conventional garden plants develop shallow lateral roots, chasing the nearest surface moisture, which means they are perpetually stressed because surface moisture is perpetually evaporating. When water is consistently available below the planting square, roots follow it downward. Deeper roots mean greater drought resilience. Plants can tolerate gaps between watering events that would kill a conventionally planted crop. This is not theoretical. Kenny Boakati, a Zuni archaeologist who grew up working in his grandparents' waffle gardens, has described how traditional Zuni corn varieties in these gardens would survive weeks of no rainfall that would devastate conventionally planted crops in the same region. The design was not just about collecting water, it was about training the plant. And now, the thing I promised you earlier, the unexpected mechanism. The one that stopped me when I first came across it in the research. Desert soils have a well-documented behavior called soil crusting. When exposed soil is hit repeatedly by raindrops or direct sun, the surface particles bond into a thin, dense layer that actually resists water infiltration. You have probably seen it. That almost lacquered look on bare ground after a storm. Water sits on top of that crust and runs off sideways instead of soaking in. Conventional flat gardens fight this constantly. Gardeners are told to till, to aerate, to break the crust before it sets. The Waffle border solves this passively. The raised earthen walls intercept raindrop impact at the edges of each square. The surface inside the square is protected from direct heavy impact during rain by the surrounding berms. The soil inside stays porous, and that porosity allows what soil scientists call macropores, small air channels in the soil structure, to remain open, pulling water downward by capillary action rather than repelling it. One system, solving two problems simultaneously, without a single piece of modern engineering. Have you ever tried growing food in a dry climate and felt like the soil itself was working against you? Tell me in the comments, because what I am about to show you in the practical section will feel like the soil finally switching sides. There is one more piece of validation I want to mention before we get to the how. In 2011, a study published in Ecology and Society examined sustainable small-scale agriculture in semi-arid environments of the American Southwest. Researchers noted that traditional Pueblo growing systems, including sunken bed designs, demonstrated measurably superior moisture retention compared to equivalent conventionally irrigated plots. These were not romantic heritage projects. These were documented agricultural outcomes: more food, less water, no inputs beyond what the earth and sky could provide. Modern researchers at the University of Arizona's Cooperative Extension have also documented that ola irrigation, a companion technique to waffle gardening that I will cover in the advanced section, can reduce water use by 60 to 70% compared to conventional surface watering. 60 to 70%. With a buried clay pot. All right, let's build one. And I want you to understand, this is not a weekend Pinterest project. This is a functional, centuries-tested food system. And if you treat it that way, it will reward you the same way. Here is what you need. Start with a site assessment. Waffle gardens were traditionally built in low-lying areas, near natural water flow. Not because they need running water, but because those sites tend to have slightly higher soil moisture and lower wind exposure. If you have a natural low point in your yard, near a downspout, or along a wall that blocks prevailing wind, that is your site. If you do not, a flat open area works fine. You want at least 6 to 8 hours of sun exposure, but afternoon shade from a fence or tree line is a bonus, not a problem. For a starter waffle garden covering roughly 40 square feet of growing space, you need the following. A digging tool. A flat spade works best, not a pointed one. About 20 to 30 pounds of slightly dampened clay-rich soil or subsoil for building your borders, which in most regions you can source from the first 12 inches of a dig in your own yard. A measuring tool. 2 to 3 bags of mature compost. And optionally, and I will explain why this is worth doing, 2 unglazed terracotta pots with drainage holes plugged for ola irrigation in your central squares. Total material cost if you source your border soil from the site itself, roughly $15 to $25 for compost and the optional clay pots. Here is the process, and I am going to be specific because most guides get this wrong. Start by marking out your overall garden perimeter. A 4 by 10 foot rectangle is manageable for a first build. Now here is step 1. Excavate the entire area to a depth of 4 inches. Set that topsoil aside. You will mix it back with compost in a moment. This lowered base is your working level. Everything in this garden will sit below your surrounding yard, which is exactly what you want. Step 2. Using the subsoil you set aside, the less organic, more mineral-heavy stuff from the lower part of your dig. Begin building your waffle borders. These are walls that divide your lowered space into individual squares. Make each square 14 to 18 inches per side. The walls should be 4 inches wide at the base, compacted firmly with your hands or a small tamper, and standing 4 to 5 inches tall above the bed floor. Wet the soil as you build to help it hold shape. This is critical. Dry, loose borders will collapse after the first rain. Moist, compacted borders will harden to something close to adobe. Step 3. Backfill each individual square with your original topsoil, mixed 1-to-1 with mature compost. Fill to about 1 inch below the top of the borders. You want a slight concave surface that cups inward, directing any water toward the center of the square and away from the base of your borders. Step 4. Planting. 1 plant per small square for large crops like squash or tomato. 3 to 5 plants per square for companions like beans or herbs. One of the beautiful properties of this system is that the plant density per square can be higher than conventional spacing would suggest. Because the moisture retention means competition for water is not the limiting factor. The Zuni traditionally grew corn, beans, and squash in adjacent or shared squares. The Three Sisters system, not as a poetic concept, but as a practical stacking of root depth, nitrogen fixation, and shade provision. Most people get the border width wrong. Narrower borders look cleaner, but erode faster and allow lateral water loss. 4 inches minimum. 6 is better if your soil is sandy. The second common mistake is overwatering in the early weeks and concluding the system does not work because the soil stays wet. The waffle is designed to retain moisture. In the beginning, you may only need to water once every 4 to 7 days, even in summer, depending on your climate. The instinct to water daily is exactly what this system is asking you to unlearn. For experienced growers who want to take this further, add olas. Ola, pronounced olla, is a Spanish word for clay pot, and the practice of burying unglazed terracotta vessels as subsurface irrigation reservoirs is documented in China, Sub-Saharan Africa, India, and the pre-Columbian Americas across thousands of years of agricultural history. You take a porous, unglazed terracotta pot. Seal the drainage hole with a cork or food-safe sealant. Bury it in the center of a larger waffle square, with only the neck visible above the soil surface, and fill it with water. The water seeps through the porous walls of the pot slowly and continuously, directly into the root zone, at a rate governed by the moisture tension of the surrounding soil. When the soil is dry, it draws water faster. When it is moist, the rate slows. It is a passive, self-regulating drip system that costs under $10 per unit and requires no electricity, no tubing, and no timer. Studies show ola irrigation can reduce water use by up to 90% compared to surface methods. If you live in a dry climate and you build a waffle garden with olas installed, you have built something that 800 years of field testing has already validated. For climates with cold winters, before the first frost, simply drain and remove your olas, and mound the border walls lightly to protect their structure from freeze-thaw cracking. The garden itself, unlike a raised bed, has no structural components that freeze damage can destroy. Now, what does the first year actually look like? Because I want to prepare you for something that trips up almost everyone who tries this for the first time. In week 1, the soil will look different from anything you have grown in before. If you built the borders correctly, there may be slight surface cracks as the adobe-style walls cure and harden. This is normal. This is good. The walls are becoming more structurally sound, not failing. Do not wet them aggressively in week 1. Let them cure at a natural pace. By week 2, if you have planted warm season seeds or transplants, root development will already be establishing deeper than you are used to seeing. If you have an herb or small annual in there, the leaves will be compact, slightly darker green, and standing firmly. Plants in waffle squares tend to look less lush than hydroponically or heavily irrigated plants. But that is appearance, not health. They are building root systems instead of decorative foliage. By month 2, the difference becomes difficult to ignore. The borders will have weathered 1 or 2 rain events and possibly several watering cycles. And you will notice something that contradicts the logic of conventional gardening. The soil inside each square stays workable and moist at the 3-inch depth, even in dry stretches that turn surrounding bare soil to powder. That is the capillary and shading mechanisms functioning together. That is the system doing what 8 centuries of refinement trained it to do. What might look like failure, but is not, is surface dryness. The top inch of soil inside a waffle square can look dry even when the root zone 3 inches below is adequately moist. New gardeners panic and water excessively, disrupting root development and softening the borders. Push a finger into the soil before you water. If moisture is present below the surface level, wait. Trust the design. And here is where I want to bring back what I said at the beginning. This system is constrained in cities where zoning requires front yards to be kept clear of earthen structures, where soil alteration is treated as a property violation, where the visible markers of a working food system, earthen walls, productive plants, utilitarian beauty, are classified as code violations. Not because they are dangerous, because they do not look like what a lawn is supposed to look like. The Zuni did not have a lawn. They had food. They had water. They had a system that asked very little and gave a great deal back. The question of why that approach became legally awkward in the 21st century is not really about gardening. It is about what we decided a neighborhood is supposed to communicate, and whether we are willing to quietly, politely, grow past that assumption. There is something profound in the fact that a farming technique developed in the high desert of New Mexico over 800 years ago is still more water efficient, more ecologically sound, and more climate resilient than anything the modern garden industry has produced, not marginally, dramatically. The people who built these gardens did not have access to soil science journals, or precision irrigation technology, or government agricultural extension services. They had time. They had observation. They had the willingness to pass knowledge from grandmother to granddaughter until the knowledge became part of the land itself. That kind of wisdom does not expire. It waits. It waits in the soil structure of old Pueblo sites, in the memory of a Zuni archaeologist helping children dig their first grid, in the notes of researchers who found themselves quietly embarrassed by how well a clay pot and a sunken square could outperform decades of engineered irrigation products. You now have something that most people who buy seeds and shovels this spring will not have: the geometry of patience. The understanding that working with physics, with shade and capillary action and gravity, produces results that working against physics never will. The waffle garden is not a clever hack. It is the result of a civilization taking its relationship with water seriously, with soil seriously, with permanence seriously. Build one this season. Start small. A 4x4 patch is enough to see the mechanics work. Show someone else once it takes hold. Carry the knowledge forward the same way it was carried to us, by demonstration, by generosity, and by the simple act of growing something real. If this channel means something to you, subscribe, because what we do here is unearth what was nearly buried. And the next video is going to take you underground in a way that will make this one feel like the introduction. There is an ancient water system, spanning 3 continents, that modern engineers have spent 50 years trying to recreate. And they still cannot fully explain why it worked.